Somebody with no engineering background can now describe an app to a chatbot and have it running in 10 minutes. I've been a full stack engineer for almost 8 years, so let's ask the honest question. Do I still have a job? The answer is yes, but not for the reasons most engineers want to hear. It isn't because AI is bad at this. AI is getting genuinely very good at this. It's because the job market moved. And I don't think most of us have said out loud where it moved to. Let me start somewhere that might surprise you because this isn't only a full stack problem. If you are front-end engineer, you have probably noticed that backend tickets stop being somebody else's problem. And if you are backend engineer, somebody has definitely asked you to just fix the spacing on a page. That used to be a career change, now it's Tuesday. Because the wall between these roles were really never about the capabilities. It was about the cost. Learning a whole other half of the stack was expensive, so we specialized and we hired specialists and we drew a line down in the middle of the team. AI made crossing that line nearly free, which means it isn't a wall anymore. So full stack stopped being a specialty, it quietly became the floor. And that's the actual shift I want to talk about. Because being handed work in a layer you don't understand is very different situation from choosing to learn that layer. So let me tell you what this job actually was, because that's the part that didn't transfer. Full stack meant owning a feature from database all the way to the pixel rendered on a browser. But underneath that, it meant carrying a mental model of all the entire system. And I want to make that concrete because systems thinking gets described in the vaguest possible term, then nobody knows what to actually go and learn. So here's a real one. You ship a feature, it works, it's fast, and everybody is happy. 3 months later, it is slow, and it is slow for everybody, not just that feature. You go and read your code, and your code is fine. The logic is correct, the queries are indexed. Nothing is wrong with what you wrote. The problem is that your database connection pool is set to 10 and now you have 50 requests arriving at the same time. So 40 of them are sitting in a queue waiting for the connection, doing nothing. And because they're holding a worker thread while they wait, your server runs out of the workers. And now requests that don't touch the database at all are also slow. Nothing in your code is broken, your system is broken. And you will never find that by reading the file where the bug appeared to be. That's what systems knowledge is. It's about knowing that the answer isn't always in the code. And it's a whole category of things. Knowing that a slow service is more dangerous than a dead one, because a dead one fails immediately and something alerts, while a slow one just quietly poisons everything upstream of it. Knowing that retries make outages worse, because when something is struggling, the most helpful thing you can do is stop asking it for things. Knowing that caching solves your problem and it creates a new one, which is that exactly one customer is looking at the data from yesterday and nobody can reproduce it now. Knowing what happens under the load that never happens on a laptop where you are the only user and database has 14 rows in it. You build that intuition one incident at a time. Usually at an hour of the night you'd rather not be awake. Then there's knowing your stack. Not knowing that React exists. Knowing why your framework renders when it does. What your ORM actually sends to a database because it is frequently horrifying. How your runtime handles concurrency. What your build tool ships to the browser and what it quietly leaves in. That's what let you look at bug and say, that's not a logic error, that's a race condition, or it could be a n+1 query, or that's a hydration mismatch. You cannot search for a bug you cannot name, and you can't ask an AI about it either because you'll describe the symptoms and it will confidently fix the symptom. And then security. which most people treat as somebody else's department right up until the day it isn't. Authentication, sessions, access control, input validation, what you store, what you log, and what you accidentally expose. I built rotating session tokens for an insurance company where getting it wrong wasn't a bug, it was a regulatory problem. That work permanently changes how you read code afterwards. You stop asking only, does this work? You start asking, what does this let somebody do that I didn't intend to? So, a first version of a product used to take weeks to months. Now, not because typing is slow, because deciding is slow, and every choice you made, you'd live with it for years. And here's what people who have never maintained software don't understand. Writing it is an easy bit. Keeping it alive is the job. Dependencies rot. Libraries develop security holes. Frameworks ship breaking changes. That temporary fixes somebody else put in there 3 years ago is now load-bearing infrastructure, and there's a comment about it that says, do not remove, with no explanation written by the man who left the company 5 years ago. I've built an entire codebase from an old component style to a modern one, not to add a single feature but to stop it from becoming unmaintainable. And then the hardest problem in this industry, the person who built it leaves. A new engineer inherits a codebase they have never seen. No context, half the reasoning behind every decision lived in that person's head, and it walked out of the door with him. So they are scared to touch anything because they don't know what breaks if they do. They build around the old code instead of fixing it. Every team has a file nobody will open. This is why we had those paradigms: clean architecture, design patterns, code reviews, and test. None of it was just an academic box ticking. They existed so code could be understood by somebody who wasn't there when it was written. Hold on to that because it's about to become the whole point. Then the AI assistant arrive. And I'll be honest, they are extraordinary. I use them every day and I'm not giving them up. The grunt work collapsed. Boilerplate that took an afternoon takes a sentence. I can scaffold an API, generate test, refactor a function, or explore an approach I'd never have had time to try. And here's what the job actually moved. It used to be the hard part of this full stack was the building. Holding 4 layers in your head and being competent in all of them was genuinely difficult, which is exactly why it was a specialty. That part got cheap, not easy, cheap. That's a difference, and the difference is a whole video. Producing code in a layer you don't understand is now trivial. Judging code in a layer you don't understand is exactly as hard as it always was. So the skill didn't disappear, it moved from producing side of the line to the judging side. And that's why this lands on everyone now, not just people who call themselves full stack. Because you're going to get handed that backend ticket and the machine will write it for you. You will have to decide whether to ship it or not. Now, which brings me to the skill people are still describing wrong. They call it prompt engineering, and the casual version, typing clever instruction in a chat box, is mostly dead. Not dead as in useless, dead as in models got good enough that the tricks stopped mattering. Role-playing preambles telling it you'll tip it, 40-page mega prompt stuff into everything just in case. That was folklore. Modern models follow plain instruction more literally than they follow theater. The industry actually renamed this, and it's worth knowing who. In June of 2025, the CEO of Shopify publicly said he preferred the term context engineering because it describes the core skill better, providing all the context needed for the task to be solvable at a time. Then Karpathy amplified it. By July, Gartner had published a line saying context engineering is in and prompt engineering is out. And my favorite description of what went wrong came from Simon Willison, who pointed out that prompt engineering had been redefined to mean typing prompts full of stupid hacks into a chatbot. The serious discipline underneath got buried under 2 years of threads about a magic words. So what does the serious version of it looks like? It's persistent version document that live in your repository. And I know I can hear it, documentation. The thing we all agree is important, put on the roadmap every quarter and have collectively never once finished. The biggest single lie in the software narrowly ahead will refactor it later and this is just temporary fix. Every readme that trails off with to do add setup instruction written enthusiastically on day one and never touched again. I want you to hold that feeling because it's about to become funny. There's a standard for this now. It's called AGENTS.md. It was formalized in 2025, handed to the Linux Foundation at the end of that year, and it's been adopted by over 60,000 repositories and read natively by more than 20 different coding tools. I write one for every project, and it isn't a prompt, it's an engineering document. The architecture, why it's shaped that way, the exact build, test and lint commands with the right flags, the security policies, what never gets committed, what never ships in the build, what endpoints require auth, what we do and don't log, and the boundaries, what nothing is allowed to touch without a human deciding. One practical note, if you go and write one, keep it short. Research across a couple of thousand repositories found that once these files get past about 150 lines, you stop getting better result and you start paying roughly 20% more per request for the privilege. Start at 30 lines, add sections when the agent consistently gets something wrong, delete a section when the convention changes, treat it like a code, not like a documentation. And now the part I genuinely find funny. Remember the handover problem? The engineer who leaves and takes all the reasoning with them? The paradigm we invented so code could be understood by somebody who wasn't there. That's what this file is. We spent 40 years writing documentation that nobody reads. Then we stopped writing it because nobody read it. And now we finally have a reader. One that all reads all of it. Every single time. Without complaining, without skimming to the code examples. And then does exactly what it says. The most reliable colleague any one of us have ever had, and it turned up about 18 months ago. So the artifact changed. It used to be that what you produced was code and documentation was the thing you'd get it later and never did. Now code is nearly free and the document is the leverage. What you're actually paid to produce in precise, consistent, honest description of how your system works and what must never happen to it. Which brings me to the uncomfortable part. You cannot write that document if you don't understand your own system. You can't write down how a request travels if you have never traced one. You can't write the security policy if you don't know what you're exposing. You can't define the boundaries if you don't know which parts are load bearing. And you definitely can't write a line about a connection pool if you have never watched one run out. That's why the fundamental didn't get easier to skip, they got harder. It used to be possible to be a decent engineer who muddled through copied patterns without fully understanding why they worked because you were ever asked to produce code that run. Now you're being asked to write the reasoning. The machine will happily generate the code. It cannot generate the understanding on your behalf. Because the understanding is the input, not the output anymore. So full stack engineering isn't dead. It stopped being a job title, became a baseline. It used to mean you could build every layer. Now it means you understand every layer well enough to write down how it works, direct a machine that's building it, and own what ships. The security, the stability, the parts the demo never shows you. The tool made the typing free, which means that knowing is now the entire job. And if you have been avoiding the other half of the stack because it wasn't your area, I've got some bad news about your next ticket.